Hey guys, welcome back to a new video. In this video we will set up Retrofit, so our library to make network requests. So we are actually able to make these API requests to our Poke API, which I showed you in the previous video. You can see I opened that here in Chrome. That is just pokeapi.co. That is an API that does not need any API key or authentication. Instead, you can directly use it. As you can see here, you can just query a specific Pokemon, for example, Ditto or Charmander, like this one, submit, and that will be the corresponding API response here. What we want to do here and what we want to start with is when using Retrofit, and especially when using JSON as we do in our project here, if you remember, we have that dependency, this converter JSON, which basically just takes the incoming JSON data. So JSON data is this data here in text form, and it will convert that to Kotlin data classes. So of course, with data classes, we can deal in a much easier fashion than with such a string here. But to actually be able to convert these JSON responses using JSON to our Kotlin data classes, JSON needs to know how these data classes look like. And for that, what we will do is we will take all that response stuff here, copy this. That is actually not that good. We want to click on direct link to results here. And that is the raw JSON response here. We can, oops, didn't want to do that. We can simply hit Control and A to select everything. Control C to copy that response, and then we want to go back to Android Studio, create a package here in our root package, right click, new Kotlin class of file, a package of course, not a class, this one. This will be our data package. Inside of that data package we will have a remote package for our API stuff, and in that remote package we will have a responses package. In that response package, we will then put all the different data classes that JSON can actually parse to from our API response. And the disadvantage of this API here is that we get quite a lot of data here in a single API response that we are actually not interested in. But that is something we just have to deal with here because we don't have any influence on that API, and this API is still one of the best Pokemon APIs out there. So after this course, you can definitely extend this app because you have so much data in your app that we don't display yet and won't display in this course. But still, we need all these classes here in Android Studio. So let's get back, right click to responses, and you can see I have a plugin installed called Kotlin data class file from JSON. If you don't have that plugin, you want to hit Control Alt S to open your Android Studio settings. You want to go to plugins, go to marketplace, and search for Kotlin JSON to Kotlin class. This plugin, you can see I have it installed. If you don't have it installed, click install, restart Android Studio, and then you will also have that option as I do here, and that will basically just take in a JSON string here, which I copied from that website. You can see that has 11,000 lines of code. And then we need to give the root class for our response a name. And this plugin will generate all the remaining classes for us inside of that responses package. And those will actually be a lot of classes here. I will give this root class the name just Pokemon because this request here represents a single Pokemon. You can see this is Charmander here. We get a URL to that Pokemon, and we get all the data related to Charmander. So that will be the data that we need to query when we click on a Pokemon detail view. So we hit generate, and then it will take a little moment. And you can see it generated the classes. It's still doing all that, adding files. And you can see those are a lot of classes here. But that was only for our first response, which corresponds to a single Pokemon. We also have a different kind of response, which doesn't bring as many data classes here, don't worry. But the other response we get actually corresponds to the list of Pokemon, which displays on our main screen. So we go back to Google Chrome, to our Poke API main website here. We can actually do this here as well. We just want to remove the Pokemon name from the URL. So just this URL /Pokemon, hit enter, and you can see this gives us a list of Pokemon and URLs to these corresponding Pokemon. You can also see this response is much smaller than the response we had first, because we get these Pokemon paginated here. You can see we have a limit of 20, so we get 20 Pokemon at once, and then when we scroll that far, we can just load the next 20 and so on. So again, I will hit Ctrl A and Ctrl C, go to Android Studio, right-click Responses, New Kotlin Data Class File from JSON, paste this. You can see only 87 lines this time and not 11,000. And I will give this a name of Pokemon List and click Generate. And you can see now only, I think, 2 more classes came into our package. Now we can collapse that because it's quite big and actually set up our API, our Retrofit interface, in which we will define the functions, how we can access our API. So in our remote package, not in our responses package, we will create a Kotlin class or file, select interface, call that Poke API, and press enter. Now, in case you're not familiar with Retrofit, the way we do this is, instead of this interface, we will just specify the functions with which we will access our single routes from our API. So we will have 2 functions here, one function to get a Pokemon list and one function to get a Pokemon data, basically for the Pokemon detail view. So what we will have here is we will have a suspend function, because that will be executed asynchronously in a coroutine, called get Pokemon list. And now we want to be able to pass parameters to this function to, on the one hand, assign the page size, so how many Pokemon we load at once. And on the other hand, we want to define the offset, so from which Pokemon we basically want to start. So for the first call, we will just have an offset of 0, load the first 20 Pokemon, and then we will increase the offset by 20, so we will load the next 20 Pokemon, and so on. And in Retrofit, or rather in HTTP, we do this using query parameters, which we can use with this add query annotation, which we can import here and do it like this. We don't want to import this room query parameter here, this room dependency. Instead, we want to click on import. We want to import that from Retrofit, not from room. Don't do this. And in here we specify the name of the query parameter, which is a limit in this case. Call this limit. This is an integer, so just a page size. And we will have another query parameter called offset, which will also be an integer. And then this function will simply return our Pokemon list. And now with that, we haven't told Retrofit yet to which route this request should actually go and what kind of request that actually is. So we do that up here. We annotate this function with @get, because that is a get request. We want to get data. We don't want to post any data or update any data. And here we specify a string, which is the part of the URL this request should go to. So we will specify a base URL in this video, which will just be the first part of our URL that is basically always the same. And let's just see that. So our base URL would be this. And our request in this case to get this list of Pokemon would then go to the base URL and this Pokemon here. So what we pass here is just Pokemon. And then we will write our other function to get a specific Pokemon and the data for it. Also suspend function, get Pokemon info, I will call it. And that will be a get request as well. This will go to, as you can see here, We had that before, Charmander. This would give us the Pokemon info for Charmander. So now this is not a query parameter, that is what we call a path parameter in HTTP, because the parameter Charmander here, we want to get the data for Charmander or for any other Pokemon, is part of the actual URL and it's not a query parameter. And because of that, we want to use Pokemon as our route / and because the Pokemon name is a variable here basically that can change for each Pokemon and for each request we make, we specify that here as our own path parameter. And then we can say at path here, we want to replace the name parameter here in our URL with the name we pass here as a parameter. So whatever we pass for this name will be inserted here in our URL. And that will then return a Pokemon. And now I want to create our actual repository in which we'll make the network requests. I will do that in its own package. Let's create that repository package. And in that we will create our Pokemon repository. And usually you would create an interface here for that repository and then let our real repository implement that interface, which is good for testability of our application. But just for simplicity reasons here, I will just make this a class. And yeah, we won't have any testing here in this playlist. This repository will then be injected into our view model later on. And it will be scoped to our activity. So it will live as long as our activity does, which is just the same as our application's lifetime here because we only have a single activity. But we want to annotate this with activity scoped and then inject dependencies into the constructor of this repository. Because in here we want to get an access to our actual API instance, so private val API of type PokeAPI. So in here we will have the actual implementation of our API, or rather of making the network requests. On the one hand we have our suspend function get Pokemon list, which will take the limit and the offset, both of type integer. It will return our Pokemon list response type. And in here we can then get the response using a try and catch block. So we want to catch exceptions in case something goes wrong. For example, when the user is not connected to the internet, we will make the request using our API .get Pokemon list, passing our limit and offset, and catching any exceptions here. Now we actually want to be able to somehow tell our view model later on in our composables about errors that happen here. So how can we actually do that? For that I will use a common class I use in all of my projects, which is called resource class. That class will be used for, on the one hand, for error handling, for success handling, and for loading handling. So it will be a generic wrapper class around the response type here, which now sounds super complex. It's actually super easy. Let's do that in our util package, which we don't have yet. Let's create that util, and in that util package we create this resource class. If you know my playlists, you know this resource class. That is a sealed class. If not, don't worry, I will explain it. So that will just be a generic class with a type parameter t here. That means we can wrap this around any object we like. And it will, on the one hand, take a data parameter of this type t, which is null by default. And it will take a message parameter, which is of type string and nullable, and null by default. And now in here we can define different versions of this class basically for each state our response can be in. So on one hand, we can of course have a successful response. So we can create a class success, also of type t, and that will take a mandatory data parameter here of type t. And this time it's not nullable, because when we get a successful response, we also know that we get data that we want to attach to that resource class here. So the data will just be our Pokemon list in our case. And this class will just inherit from resource of type T, and for that we will then pass that data here and null for the message. And we get an error here. Data hides member. Oh, we don't want to make this a val because we can already access this data here by its parent class. Otherwise we would need to override it here. Now we want to have, we can duplicate that, Control D. Now we want to have an error state as well. So if something goes wrong with our request and response, this time passing data is not mandatory, because if we get an error and something goes wrong, we don't know if we have any data to attach. Usually we don't have that. So we want to make this data parameter nullable and null by default. But what is mandatory now is a message, because when we get an error, we want to tell our view model and our composables about what actually went wrong. And then also pass that data and that message here. And finally, we will have a class loading here, which will take only an optional data parameter. And that will just be emitted initially, so we can display a progress bar. And then when either error or success is emitted, we can hide the progress bar again. So resource.t and pass our data. And that class, which now looks quite complex, if you're not that familiar with generics, is super helpful. You can use that in every of your projects, and I'll show you how. What we want to do is we want to wrap this this return type into a setResource class. So we import that and say resource of Pokemon list. And now in case we catch an exception and something goes wrong with our request, we can simply return resource.error, and here we can just pass an error message, what went wrong. And I won't do any detailed error handling here. I will just write an unknown error occurred. You could do this error handling here in much more detail, but I won't do this here in this rather simple playlist. And if we didn't catch an exception here, that means everything went well. We can simply return resource.success. And now we need to attach data of type Pokemon list, which is exactly our response. So the result from this API call. So we pass response here. And that is already it for this get Pokemon list function. Let's do the same for our other function. Copy that and paste it down here, which will be called get Pokemon info. This will take a Pokemon name. So the name of the Pokemon we want to get the info for and the data. That will return a resource of type Pokemon this time, because this time Pokemon is our return type of our API call. Here we pass API get Pokemon info and pass our Pokemon name. And that is already it for this function. And now the last step for this video is to actually provide our API in our repository in our app module, just to tell Daggerhill, hey, these are the dependencies we want to be able to inject into our classes, and specifically view models in our project here. We do this with so-called provide functions. So that's the naming convention. We call them function provide Pokemon repository, for example. That will take our API, because to construct our Pokemon repository, we need our API of type Poke API, and that will just return our Pokemon repository, and we pass our API. And then we can annotate this with @singleton, because this repository will be a singleton, and with @provides to just tell Daggerhill that this is a provides function. And we also want to have another function, provide Pokemon Poke API, I called it, to just provide our actual API, our retrofit instance, with which we can then make the network requests here in the repository. and that will return our Poke API. And here we can just return retrofit.builder. We want to add a converter factory, which is our JSON converter factory that creates. So that will convert the JSON code to our data classes. We want to give the base URL, for which I will create a constants file in our util package. Kotlin class constants, select object, and we create a const val base URL, which will be https pokeapi.co/API/v2, I think it is, like this. And then we can pass that here for our base URL and import that. We also want to call .build, because that is already it, and .create, where we can specify the API interface, so Poke API class at Java. And then finally annotate this with singleton again and with provides. And that is it for this video for setting up our API. So now we are ready to actually make network calls. In the next video we will then begin to write our UI, so all the compose stuff. And yeah, I hope you enjoyed this video. I wish you an awesome day, and I hope that I will see you on the next video again. Bye bye.